In this video, we look at RL circuit. First of all, we look at a source-free RL circuit. In this case, there's an initial current flow through the inductor equals I0, which means that at time equals 0, there's an initial current I0 in the inductor. If we look at a circuit of RL circuit, so this is RL circuit, and this is source-free because there's no independent source applied to this circuit. And pay attention to the direction of current I and the sign of voltage along the inductor because they follow the passive sign convention here. If we compare the source-free RC circuit and source-free RL circuit, we can see they are very similar. The only difference is the device. So this is a capacitor and this is the inductor. Remember that in RC circuit, we look at the voltage, the transit at the voltage along the capacitor. For RL circuit, we look at the transit of the current flow through the inductor. We apply KVL in the loop, which means that VL plus VL plus VR equals 0, and then we apply Ohm's law for the inductor. VL equals to L di dt, and plus Ri. This is Ohm law for the resistor, and this is first order differential equation. And follow the same step as we solved for RC circuit, we obtain that I of t equals to I0 e to the power minus RT divided by L. So this is exactly I of t equals to I0 e to the power minus RT divided by L. And this is equals to I0 e to the power minus t divided by tau. And tau, that's the time constant, L divided by R. This is a source-free RL circuit response. Now let's look at the discharging and charging between the inductor and the resistor. We know that using Ohm's law, the voltage on the resistor equals I of R. We know I already, so we just plug it in. That's equals to this quantity. Then we can find the power consumed at the resistor. Power equals to V multiplied by I. VR multiplied by I. We plug it in. That's equals to this quantity. And now let's look at the energy absorbed by this resistor. We do integral of the power with respect to time. So that's equals to this quantity. And IT goes to infinity, and e to the power minus 2t divided by tau, this portion, this e to the power minus 2t divided by tau, this goes to 0. So IT goes to infinity, e to the power minus 2t divided by tau goes to 0. So therefore, at time goes to infinity, the energy absorbed by the resistor is half L multiplied by I0 squared. And this is exactly the energy stored initially at the inductor. So we can see with time going, eventually the energy stored in the inductor is transferred completely to the resistor. This is a source-free response of RL circuit.